Have you ever found yourself battling a super slow, really complex query on a massive data set? I mean, who hasn't, right? It's so frustrating. Well, today, we're going to dive into a solution that can completely change the performance game for you.
Yeah, we've all been there. You've got terabytes, maybe even petabytes of data, and your analytics platform just can't keep up. Those queries that are supposed to give you these amazing critical insights, they end up timing out or just taking hours and hours to run.
So that raises a really important question. What if the query itself isn't the real problem? What if it's all about how the data is physically stored on disk? Could we unlock some incredible speed without even rewriting a single line of SQL?
Okay, here's our game plan. First, we'll talk about those common performance killers. Then, we're going to explore Vertica's really cool columnar approach, which leads us right to its secret sauce, projections. After that, we'll see how to actually design with them, and finally, we'll wrap up with the massive payoffs.
Right, so before we jump into the solution, let's properly diagnose the problem. Why do our big data queries slow down to a crawl?
Well, there are a few usual suspects. Sometimes the database just has a bad execution plan because its internal map of the data, its statistics, is totally out of date. Or you get these bottlenecks, something called data skew, where one part of your system is just completely overloaded while everything else is just sitting around waiting. And then there's the classic. Operations run out of memory, have to use the slow disk, and everything just grinds to a halt. To fix these kinds of problems, Vertica really starts at the foundation. It's what's called a shared nothing database, which basically means each part of the system works independently to get maximum speed. But the real magic, the thing that changes everything, is how it physically organizes the data. And this slide shows that fundamental shift. Traditional databases, they store data in rows. That's great if you need to fetch one whole record at a time. But analytics queries, they usually only need a few columns from like millions of rows. So by storing data in columns instead, Vertica reads only the exact data it needs, which absolutely slashes the amount of disk I/O. It's a game changer. This whole columnar foundation really just sets the stage for Vertica's most powerful feature. Its secret weapon, really. And that is projections. Okay, so this is the crucial point. You have to get this. In Vertica, a table is just an idea. It's a logical blueprint. A projection is the actual house. It defines the physical reality of your data, how it's encoded, compressed, sorted, and spread across your entire cluster. This is where all the performance tuning actually happens. Now, to really get this, we've got to look at what's called the Data Definition Language, or DDL. And don't worry, it looks way more complex than it is. It's actually pretty simple, but each little clause has a massive, massive impact on performance. First up is order by. Now, this isn't just for displaying your results at the end. This command physically pre-sorts the data as it's being written to disk. So why does that matter? Well, it groups all the similar data together, which gives you way better compression and makes things like merge joins and group by operations lightning fast. And look, this visual illustrates it perfectly. On the left, you've got data just as it arrived, kind of all over the place. But on the right, after the order by clause does its thing, you can see how the records are physically reordered and grouped. The database now knows exactly where to find related data, making reads unbelievably efficient. All right, next up is the segmented by clause. This is all about parallel processing. It uses a hashing function to decide which node in the cluster is going to store each piece of data, which spreads the workload out nice and evenly. This is how you prevent those hotspots we talked about earlier. The trick is to segment by a column that has a ton of unique values, what we call a high cardinality column, to make sure you get a really even spread. Now, the alternative to segmenting is replicating. With unsegmented all nodes, you're telling Vertica, hey, put a full copy of this data on every single node. Now, I know that sounds incredibly wasteful, but for your smaller dimension tables, like in a star schema, it is a huge performance win. It allows for local joins everywhere, which completely eliminates the need to move data across the network. It's amazing. So these building blocks let you create all different types of projections. A super projection is kind of your safety net. It has all the columns, so it can answer any query. But the real power comes from creating these query-specific projections that have just the columns and sort orders you need for your most important queries. And for dashboards, aggregate projections are incredible. They pre-calculate things like sums and counts, giving you pretty much instant results. Okay, so we get what projections are. Now, how do we actually use this knowledge to design a super high-performance data warehouse? Let's get practical.
Ah, the classic debate in analytics. Do you keep your data all normalized and clean in a star schema with your facts and your dimensions? Or do you just denormalize everything into one giant wide table to avoid doing joins at all?
Well, what's interesting is there's no single right answer. It really depends on the database. For most of the traditional columnar databases, a star schema is usually going to win out. But for some of these newer NewSQL databases, a flat table can actually be faster because they're built from the ground up to avoid those expensive joins. But beyond just pure performance, there's a really powerful business reason why the star schema is just so popular. As this user from the Power BI community points out, it mirrors how the business actually thinks. It separates what happened, the facts, from the context, the dimensions. And that makes the model reusable, scalable, and a whole lot easier for business users to actually understand. So when you put it all together, a columnar architecture with a really thoughtful projection design, what are the actual tangible results? Why should you care?
First off, massive data compression. And I mean massive. Because columnar storage groups all the identical data types together, Vertica can use these super efficient encoding and compression methods. We're talking about shrinking your data size by 10 to 30 times. That means huge savings on your storage costs. Next up is high availability, which Vertica calls case safety. And the cool thing is, this is all handled automatically by projections. When you set a case safety level, Vertica creates what it calls buddy projections. They're basically backup copies of your data segments on different servers. If one of those servers goes down, the system just seamlessly switches to a buddy copy. No data loss, no downtime. It's built right in.
So let's bring it all home. What do you get? You get extreme speed because you're designing projections that pre-sort and co-locate related data. You get massive compression, which saves you a ton of money on storage. You get built-in high availability thanks to case safety. And maybe most importantly, you get the flexibility to tune the physical database for your specific workload without ever having to change your logical model.
And that leaves us with one final crucial question to think about. When you're designing your next database, are you only thinking about the logical relationships between your tables, or are you actively designing the physical layout of the data on disk to drive performance? Because with projections, you can finally and powerfully do both.